So meanwhile, others can join. I think Vishnu has sent me a question, and I think you guys can try it too. There is a proper cantilever being. Okay, Vishnu. So only two people. Let's see. Vishnu and Ramya. And the question is that they are given this is E. Somewhere there is a point G. There is some point F, and they have given that a point load is moving, and they have given it as a unit load. And what they said is that sign convention for positive shear force on left side. That means they are given the sign convention like this. So they have given that this is a sign convention for positive shear force. And they are asking you to draw the influence line diagram for shear force at D. Can you please try it? I'll give you the options, what they have given the exam. Take a minute or take 2 minutes of time and let me know which one is right. Can you please solve this and tell me which one is right answer? No values or nothing is mentioned. Just you have to find the ILD shape. That's it. Please try to find it out. Vishnu said option B. I'm locking this for Vishnu. And others, can you please try it?
Option B, sir.
Which is your option?
D.
Sorry, D.
D for dog.
This one you are talking about, D for dog.
The same answer given by Vishnu.
Can you please type it? I'm not able to hear you. And
Sir, the same answer given by Vishnu.
okay, same answer given by Vishnu. You are also locking this one too.
Yes, sir. B.
And what about Ramya? I think Nandini is, I don't know, is this her first class? Ramya, can you please join and give your answer, please? She left? Why? Anybody knows her?
Sir, actually, I'm also getting poor signal, sir. Maybe the reason.
You're also getting?
I'm also getting the poor signal. First I
Okay.
entered, then automatically
Oh,
it
yeah,
got left.
okay. Yeah, okay. Let's see. Ramya, am I audible? Okay. Let's see. David, I think only 2 people and 3 are coming. What about Anita? Anita is not coming, right? Okay. Ramya, can I hear from you? And Andal and Vishnu, can you please think more about this?
Sir, actually, the given choices left up, right down, positive. So our load is moving left side and right side. So probably the point we have taken G, the right section is GF, the load is acting downward. So downward force is positive. So I have chosen this option B.
Okay, Vishnu, can't you speak at least this time? Ramya is going for option A. As I'm telling you, is thank you, Ramya. Another had commitment on this time. Okay, fine. If not possible, I think you guys can ask for the time change too. Aren't you guys available in the morning time? Okay, anyway, but see, what is the first thing I should do? If I want to draw ILD for shear force, what is the first thing we should do? We have to release the force, isn't it? As I want to release the force, I will release only the vertical shear force. And then I will try to draw the deflected shape. I don't know whether you guys remembered or not. I told you one thing that if it is a determinate structure, I told you that the ILD will be linear. Why? Because mechanism is causal. Mechanism is not no longer be stable case. If you are placing the hinge in a simply supported beam, that no longer be stable one. But if you are drawing ILD for indeterminate structures, I told you the ILDs will be non-linear. And one more thing I told you is that should satisfy the boundary conditions, or it should not violate the compatibility. First of all, forget about everything. One thing I will remember is that what is the type of support at E? It is a fixed support. So if you are drawing deflected shape, one thing you can identify here is that deflection is equal to 0, rotation is also equal to 0. As rotation is also equal to 0, what does it mean? Out of these options, you have to select the option which doesn't have any slope. You can see in B, there is a slope there. That means it is violating the fixed support. So this itself is not an option. Even here, option D, you can have the slope. That means this itself is not an option. Either we have to go for A or we have to go for C. Sign convention for shear force, that doesn't change. Always it is right side upward negative. As you can see here, right side downward. That means it is positive. That is the same sign convention that we have drawn. So I hope you guys know, if we are drawing for shear force diagram, right side part we will lift in upward direction, left side part we will lift in downward direction. As it is indeterminate structure, the deflected shape will be non-linear. That's why right side part is upward in only case C. So that's why case C is right, case C is wrong. And even you can observe there is a non-linear curve they have represented. Why? Because even if you place a vertical shear hinge there, still it is a stable structure. That's why for stable structure, if you want to draw the deflected shape, that won't be the linear. That will always be in some point of curve. So that's why option A is correct. Where the lacking has happened. But I expected that you guys, we could have solved this answer, right? Have we discussed anything new? No, right? It's the same thing. Whatever we have discussed in the class, that's what I have expressed here. Nothing else I have discussed. Isn't it? What about Andal? Is it okay for you now, or still you have any doubts? If not, then I think he asked me someone. Have you guys solved the question that I have given you in the last class? At least I will try.
Yes, sir. Solved, sir.
Are your answers are matching or not matching? Have you guys compared it with
Yes, sir.
each of you?
Only decimal point value is differing, sir.
If it-
Otherwise,
if it- yeah, if it is a decimal, then no, that's not an issue. That's fine, completely.
sir,
Not
I
an
have
issue.
one more doubt, sir.
Yes, Ramya.
What is the shape of influence line diagram for the maximum bending moment in respect of a simply supported beam? This is the question, sir.
Hmm.
4 options are given, sir. Rectangular,
Hmm.
triangular, parabolic, and circular.
So
If we
which one
draw
is
a
the right
maximum
answer?
bending moment diagram, it will be a triangular only, no, sir.
Yes, triangular only.
But the answer is given as parabolic, sir.
Can you please forward it and let me look into it once? Can you do
Yes.
it now? I will
1
share
minute.
with you guys. Yeah,
Yes.
fine. I think Vishnu, you have asked something that here we have unsymmetric span. Can you please tell me what do you mean by unsymmetric span? What was the question that I had yesterday? Yeah, Vishnu, those are lengthy. Just I have given you so that you guys have a lot of practice. In exam, they are not going to ask you this much lengthy, but to get you clarity, I have given the random values. And can you please elaborate your question once that what is meant by unsymmetric plane? Whatever the beam that I have given you, I have just given a simply supported beam having a length of 25 meters. That's it. The point we can choose anywhere. ILD for at any point we can consider. Given a span, that's what I'm telling you. At C, I have given you that length. If it is a C 10 meter and 15 meter, that can be 1 meter and 24 meter also. That can be 2 meter and 23 meter also. The point can be anywhere that can lie on beam. It's nothing to do with the unsymmetric and symmetric. No, no. So the question is, what is the shape of influence line diagram for the maximum bending moment in respect of a simply supported beam? No, that will be triangle only.
Okay, sir. Here
For
it is
ILD,
given as parabolic, sir.
no. It's common, right? There is nothing hard on this question. It's like a simple question, isn't it?
Yes, sir.
Okay, can we move on?
Yes, sir.
Okay, then let's come back to trusses. At least it's good that you guys are practicing. That's a good sign. We're happy to hear. Still, are you guys are afraid of influence line diagrams? Or can you guys deal with it?
No, sir. Now it is okay, sir.
And also one more thing is that every time it is not always guaranteed that we will have the what are the questions that we have solved, a similar type of questions might not come back. Once again, I am telling you, the applications of them is very much important. So don't get panicked, even if like even the problems are not directly related to the concept, but I can guarantee that we can, with the knowledge whatever we are learning here, we can simply. So now let us talk about IID for this is just nothing but a simple supported beam. Just I have exaggerated so that I can explain you something. And this is what a simple truss, or I can say simple determinate truss. And imagine that load is moving over this. Now, let us say if there is a load moving over the beam. Imagine if this is the neutral axis. Can you tell me on which fibers or on which layers will have the compressive stress or compression forces? On which fiber we might have the tensile forces? For simply supported beam. Just for a simply supported beam.
Top fiber, it is tension, sir.
Top fiber, it is under tension. And then
Bottom fiber, it is under compression.
is it right? Imagine if it is of RCC. I'm talking about single reinforced section, where we have to place the reinforcement. If it is of we are designing for RCC, where we will keep the reinforcement at the bottom layer or at the top layer?
Bottom, sorry, sir. Then it is at the bottom, compression at the bottom.
No, that's what we have already told, compression at the bottom, but here we will have tension at the bottom, compression at the top, isn't it? Now, just like visualize the same thing in the truss. The type of arrangement can be different, but even if the load is moving over the beam, if we visualize like in the frame of simply supported case, then I can say that whatever the bottom members in the same logic, I can consider that they can be under tension, and the top fiber, they can be under compression. What about the diagonal members? What do you think they will? Just like here, as it is a neutral axis, the stresses will be equal to 0, the strains will be equal to 0. Just like the same case, do we get it for diagonal members? So this is what the exceptional case, or for a diagonal members, either they will be under tension as well as they will be under compression. It's depending upon the position of the load. So in direct, if they're asking about ILD diagrams for a truss member, just like the case, if you have multiple options, let me draw two different cases so that you guys can understand. Let us say this is on positive, minus positive represents the compression, negative represents the tension. Positive, negative. Now, suppose in the exam, if I ask you to, let us say, this is number 1, and this is number 2, and this is number 3. If I giving you the options, what is the ILD for member 1? Without any calculation, can you, by looking at the diagram, can you pick up the answer? If you look at the number 1, it is in the top of the truss. As it is in the top of the truss, it will carry compression forces. For compression forces, generally we will represent it by negative. You can see positive, positive means cancel. This is not the option. And as you can see here, initially it is under compression, and then it will move on to the compression. Here, initially it is under tension, and then move on to the compression. But here it is entirely under compression. So as you can see from the diagram itself, if they ask you for member 1, this is like a rare case, but without doing any calculations, I can say that my D is the correct answer. Why? Because with the methodology, I know that member 1 will be under compression. Out of these 4 options, only option D is representing the compression. Similarly, if in the exam, if they ask you to find you what is the ILD for member 2, what can be the right answer without doing any calculation?
Option A, sir.
Just like the same way A, because as the number is at the bottom, it will be the tensile forces. That's why member A is the right answer. Now, what about for member 3? If I ask you, what can be the right answer? I can tell you, as it is a diagonal member, it can have both tension and compression forces. I can go for either B or C, but I cannot directly identify initially whether it is under compression or whether it is under tension. That will be depending upon the arrangement of the truss. As of now, is it clear? By looking at the options, how do we can eliminate some options directly if it is a ILD for truss member, right? Now, let us start with the simple case, okay? Let me erase all of this thing. First of all, let us try to draw with some basic idea that we had as of now. After that, we'll solve the calculation part. Now, just to make sure that I am representing some other color, that your unit load is moving over the span, right? Now, let us say again, B, C, D, E, F, G, H, I, J. Generally, where the load will move, to the top motor members or to the bottom members. And imagine that it can be in any direction. It can be from left to right or right to left. As of now, let us imagine. Now here, my motive is to draw the ILD for member GB. Now, can you identify if I'm talking about member GB? Can you think of any conditions that can act at the joint GB. We can apply some conditions. Look at the joint G.
It is a zero member, sir.
It is a zero member if it is a static load, isn't it? Now what is happening? Is your load is constant or is it moving from one point to another point?
It's moving, sir.
It's moving from one point to another point. The force in member GB is zero only when we are talking about static forces. Now what is happening? Your load is moving over the beam. So that's why let us understand. At instant of time, imagine that your force is here. If your force is here, can you tell me what is the force in member GB?
It is zero, sir.
It is zero. So zero. Imagine that at another instant, your load is moved to here. Can you tell me what is the force in member GB? Again, if the load is here, if the load is moved to here, what is the force in the member GB?
Zero, sir.
Zero. Similarly, if it is moved here, what is the force in the member GB?
They are also zero, sir.
Here also zero. What happens if your load is moved here?
Here it won't be zero, sir.
It won't be zero. But what is the force in the member GB?
It is
If
one.
the load is here, it is
1
one.
kilonewton.
That too, it is a tensile of compression according to the direction given. If the load is acting here, it is a tensile force or compression force. And the member
Compression.
GB.
Compression force, sir.
Is it compression really?
It is acting downward, sir. So downward force is negative. So it is compression.
No, see how come if it is a trusses, it's not about forces downward or upward. It's not. Imagine if I'm taking a rod, if I apply the force here, is it under tension or compression?
This is tension, sir.
In the same way, if you rotate the rod, if you tilt the rod in vertical direction, and if you represent the same forces, what do you think? This rod is under tension or compression?
Tension, sir.
Then how come it is under compression? No?
Yeah.
So it is under tension. So what is the force in the member GB? One.
Tension.
Now, if your load is moved to here, then again, what is the force in the member GB? If load is moved to the support, again, it's zero, isn't it? Now, join these lines. So this is what your ILD for member GB. Is it easier or difficult? Luckily, why? Because GB member forces that we can find it out directly. That's why this has become much easier. As of now, any doubt? In this case, ILD for force in the member GB. Just like in the same case, can you tell me what can be the ILD for member ID? What is the influence line diagram for member ID?
To D, we have to apply unit load, sir. And there will be a triangle, HDJ.
Yeah, triangle portion will be there in which side or along which portion. If unit load is here, then only the force in the member will be 1. And the remaining everywhere it is 0. So that's why here triangle, here triangle. So this is the ILD for ID. And HJ, yeah, it is on the portion HJ, right? So this is what one direct simple application. So these are also some common questions like, really tell me, is there any calculations needed for drawing the ILD for members GB and ID? Only we should know one thing, that as the load is moving, if it approaches that joint, then that member carries the full force and remaining everywhere it is 0. That's what the logic that we have discussed about. Now, forget about these special members and let us try to obtain ILD for members BC, members BH, and then members GH. Right? Now, for that, what I'm going to use, I'm going to use the method of sections. Okay? No doubt, right? As of now,
Yes, sir.
I thought you guys will ask me one simple or one learner doubt here, but you guys are not asking, then that's fine. That we have discussed that if it is a truss, forces will load act at the joints only. Then how come they will act somewhere here? How come the load will act somewhere around here? In reality, imagine there is a truss and train or vehicle is moving over the bridge. Then the loads will act in between the spans also. But if it is a trusses, we will consider the forces at the joints. Is it a valid question?
Yes, sir, of course.
But why? That means can't we apply the truss methodology here? So it's like these are the main members, and in between there will be some connected members over here that will be connected to these joints. So the load will first transfer over the connected members. As the load is here, then what happening? It will transfer through connected members and then it is transferred through the joint. So it's not like load will travel over the original truss, but it travel over the connected member over the truss. Understood? So this is what the difference. This is the doubt that I got while somebody is saying during my practice. So imagine these are the truss members, right? And these are the joints. Imagine. Now what happens is that whatever the vehicle that will not run over these main members, there will be another connected members that will be placed on this truss members and that will be connected at the tie joints. So as the load is moving over this connected member, as it is connected at the joints, the load will be transferred to the joints only. In between, there is no support between this connected member and the original truss member. This connected member will be connected at the joints only. So this connected member that will be act like a beam action, but at the end of the day, the main forces in the truss will transfer to the joints only. Now, yeah, let's talk about, I'm talking about this section. So just like this section, you guys can consider any section and then you guys can find out the forces, right? Let us solve it with an example only. Let us say the each length is 3 meters. Okay. Now, imagine that if your force, unit force, is at a distance of x from the point A. Can you tell me what about the support reaction that you can get here? Unit load that I can represent it actually that I should represent along this down span only, but just for the convenience, I'm representing at the upper side. Now, if there is a unit load that is at a distance of x from point A or x from point F, can you guys tell me what about the support reactions? Just like the beam, imagine there is a beam, there is a unit load, and then what about the support reactions? If the total length is L, what about this reaction? Unit force 1 into what is the opposite distance? X divided by total length. What about here? Unit force into what is the opposite distance? L minus X divided by total length, right? So what is the total length that we have considered here?
Well, sir.
All made. Now, what about the support reaction here? Opposite distance is X. So here it will be X by 12 What about here? From
12
here to here, what is the distance?
minus x.
12 minus x by total length 12. Right? Now, just please concentrate. Let me separate these two sections. Imagine initially I'm assuming the tensile forces, force in the member BC, and this is the force in the member GH, and this is the force in the member BH. This was the left side section. Similarly, if I draw the right side section, and again the same thing, this one I will represent it with my force in the member BC, and again tensile force, force in the member GH, and again this is what my force in the member BH, and then the support reaction here 12 minus x by 12, and here also the reaction will be x by 12. As of now, you guys don't have any doubt, isn't it? Now, let us say that in first case, imagine that your unit load is in between A to B. If your load is in between A to B, okay, what about the forces in the member BC? What about the forces in the member BH? What about the forces in the member GH? How can I find it out? I can find it out by considering the equilibrium equations, either by considering the left side section or right side section, isn't it? As of now, any doubt? In the first case, I'm just telling you that if my load is in between A to B, I can find the forces in the required members, these BC, BH, and GH. I can find it out by either by considering the equilibrium of the left side section or by considering the equilibrium of the right side section. Do you have any doubt as of now? No, I think no. Right? Now, if you are a smart person, which equilibrium of the section will you consider? Will you consider equilibrium of the left side section, or will you consider the equilibrium of the right side section? Vishnu is saying that left side. How do we have to decide? It's just that
Of forces.
minimal calculations, isn't it? If any answer comes by minimal calculation, then it will be better to go on that side. Now, if you look into the left side part, see here, if you're interested to find these three forces, other than these three, how many forces are acting on this system?
Reaction, sir.
Yeah, other than these three forces, how many forces are there? I can say two. What are they? One is unit load and another one is reaction. Isn't it? What if I consider the right side section? Other than the forces in the required members, that means other than FBC, FBH, and then FGH. How many forces are there? One. So, what is the condition? If the load is in between A to B, isn't it? Now, which section if I consider, then my calculation part will be easier. Right side or left side? Right side. Why? Because I'm having only one force. So that's what I will do. I will consider the equilibrium of the right side section. You can ask me a question that can't I consider the equilibrium of the left side? You can consider. There is no doubt. Still you will get the answer. But my point is, if you consider the right side section, you might end up with minimal calculation. This is what my question number B. As of now, any doubt? Whatever, considering the right side section equilibrium.
But the load is still in left side only, no, sir?
Yeah. Yes, it is still on the left side only. That's why I'm giving a condition here. If the load is in between A to B only, that's why I'm considering
yes.
the equilibrium of the right side section. And then there is a support reaction here. It is x by 12. Let us imagine the vertical ordinate is also 3 meters. Then what about this angle? 45 degrees, isn't it? Now, can you tell me what will be my force in the member? Now, can you quickly find out what about these forces? Can I give you 2-3 minutes of time so that can you guys solve this question? This is the case. What is the force in member BC? Can you please tell me what is the force in member BH? What is the force in the member GH? Can you please quickly take 2 minutes and tell me these values? We have already solved the method of sections case, right? So that's why I'm asking you just for the revision case. Can you quickly?
Sir, solving, sir.
Yeah, thank you. Thank you so much. I think I have received some answers. FBC x by 6. FBC is x by 6. Is it right? According to Vishnu, he said it is minus x by 6.
0, sir.
Which one?
FGH.
FGH 0.
Yes, sir.
And what about other two?
1 minute, sir.
Tell me one thing. If you are finding force in the member GH, which equation you have considered?
Moment equation, sir.
At what point?
At the point where FBC and BH is meeting.
This one, let us say B dash,
Yes,
right?
B.
Now, how many moments will act here? Moment will come due to this, and also moment will come due to this.
Yes, sir. Yes, sir. Sorry, sir.
You might have forgot. These mistakes we should not commit.
Yes, sir.
He is saying that it is x by 6. Cool down. See, what are the problem you guys want to solve? Cool down and solve it. If you do it in a hurry, it won't be of no use. You will end up by committing some mistake. It doesn't matter if it takes one more extra minute, it's fine. But you won't commit the mistake, you will get the marks. Always follow this conduct. Initially, your speed may be less, but you will make a habit of doing right. By practicing, that speed will reduce and you will do it in right way. Stupid mistakes will cost us a lot. A lot. They GATE exam or what are the competitive exams. Come on, guys, come on. Minus x by 6 root. Can somebody please verify these answers? Minus x root 2 by 12, I think it's the same, right? Root 2 by 12, I have solved it. Root 2 by 12 is, I think, write it as this root 2. Can't I? Andal and Ramya, what happened?
Sir, FBC, I'm getting minus x by 6, okay. But FGH, I'm getting x by 4, sir.
Yes, sir. Even I'm getting X by 4.
Because the
By-
point we have considered B dash is 9 meter from the reaction.
Yeah.
It's
yes,
not
TH
6
let me
meters.
1, 2, 3.
So then
FTH
it will come x by 4 only. Now I'm working out FBH, sir. Please.
3. Yeah, x by 4. Yeah, thank you. I'm telling you, I don't have any answers. Like I'm just all these values are I'm just giving you randomly only. So that's whatever you guys say. So that's why I'm waiting for another question. Vishnu, can you please cross verify? What about others too? If you guys please confirm it, then so meanwhile you guys do it. In the meantime, I will do something else. Please verify other two answers and let me know.
Sir, FBH is minus x by 6 root 2.
Minus 6 or 2. I think that's what I have written. It seems. It's
Yes,
fine.
sir. Minus x by 6 root 2.
Please verify one more, 1, 2, another one. Is it okay? Other equations, are they fine? And let's say this is the ILD for BC. This is ILD for GH. This is ILD for BH. Okay. Others are fine, isn't it? Now keep these equations handy. Okay. Now tell me, if my load is here, what about the X value I should consider? If my load is here, what is the X value? According
0.
to our convention, 0, right? If my
Yes, sir.
load is here, what is the force in member BC? If my load is
BC
here,
is 0. 0. 0.
see the equation. Already you are having this equation. What we are doing, we are just substituting the values.
0. 0, sir.
0. What about force in member GH?
All the forces are 0, sir. Because
0.
it
Why?
depends on
Because
x value.
everything is X, right? So X is 0. Now, if your load is here, what is the X value that we should consider?
3 meters, sir.
3. Now, substitute in the equations X equal to 3 and tell me what is the force in BC.
0.5, sir.
See the equations. I'm not looking at the equations. I'm just asking you if X equal to how much? What is the value? Minus compression or tension. Minus what is that? Compression, isn't it?
Compression.
So BC is under compression. So at this point the value is 0, and here at this point the value is minus 0.5. What about the force in member GH?
GH is 3 by 4, sir.
3 by 4, 0.75. So positive or compression or tension?
Positive, sir. Tension.
Tension. So I'm representing above the arrow. And what is that magnitude? 3 by 4. What about in the member BH?
BH is minus 1 by 2 root 2. It means compression.
Minus compression. As it is a compression, I'm writing below the line. And what is the value? Minus 1 by
2 root 2.
2 root 2. Is it okay, everybody? It's fine, right? So if the force is at X equal to 0, we know what is the force in the members. If the force is at B, similarly, we know what about the forces in the members. Now, in the first case, we have considered that your load is in between A to B. In the second case, what I will tell you, if the load is in between, which one? C to E. Can you tell me, in the first case, I have considered A to B. In the second case, I am considering C to E. Why not in between B to C? In the first case, till where I have considered A to B, right? In the second case, I am telling you to consider in between C to E. But why I am ignoring the member BC?
Because
Why
we are
not?
taking the section, sir.
Yeah, as we are taking the method of section, we are cutting the section at this junction. So that's why as we are separating at this junction, we don't exactly know where we have to keep the unit load in between the BC. So that's why wherever you are separating the section, please omit that part and then solve it for other. Later on, I will tell you how to proceed that. If I ask you to find portion member CD, which spans will you consider? If I ask you to draw ILD for CD, what is the span range that you will consider?
3 meters, sir.
Span range, matlab here just like I have considered A to B, C to E, just like that.
6 meter. C.
First you will consider A to C, and then you will consider D to E. Please omit the section, whatever the member we have to find out. Okay. Now, just like the same thing, if the unit load is here, what we have done, we have considered the right side section. Now, if the load is in between C to E, then which one will you consider? Will you consider left side part or right side part? Is there any doubt that I should explain me one more time?
Sir, one more time, sir.
Initially, where is the load? Initially, the
38.
load is in between A to
A
B,
to B,
right?
sir.
If the load is in between A to B, we have considered the right side section. Why? Because
Minimal
as we are
calculation.
simple in calculation. Similarly, if the load is here in between C to E, then which part we can consider? We can consider the left side part, isn't it? So if the load is in between C to E, what I will do? I will consider the left side part. Similarly, what is this? This is what my portion number BC, and this is what my portion number GH, and then this is what my portion number BH. And what about the reaction here? The reaction is nothing but a 12 minus x by 12. Similarly, can you guys quickly find out what is my portion number BC? What is my portion number BH? What is my portion number GH quickly?
Yes, sir.
What we are just doing is that wherever the unit load is there, we are considering the equilibrium of other section so that the calculations might get simpler. That's it. Now, similarly, can you please find out the forces in the members? As Vishnu.
Sir,
Yeah, please.
can you just show me the ILD diagram you have just drawn for all the 3 members, right? Can you go to this slide?
Yeah, here.
Yes, sir. The same.
Yeah.
Just to mark.
Yeah, not yet completed. That will complete after the number.
Okay, just note it down. Just note
Yes.
it down. Whether I
Fine.
can
Yeah.
write it or
And
write
then,
down.
others, please quickly find out the forces in those 3 members by considering the left side section. Any answers?
Sir, FGH is minus of 12 minus x by 36.
Minus of
12 minus x by 36.
once more, please verify this engage. I think it's somewhere wrong, I feel.
Sorry, sir. That value is for FBC, sir.
BC, how much?
Same value, sir. Minus of
12 minus of 12 minus XY.
36.
Is it 36 really? Or is it 12 only? Is it 36 or 12? Please once more verify it and let me know.
Sir,
Yeah, please.
I'm getting FBC equal to minus 12 minus x by 6. I'm getting
See,
And
if I want to find out FBC, yeah, I can take moment around somewhere here, right?
Around about G points, sir, for FBC.
It's
So the
dash
reaction into 6 equal to FBC into 3.
FBC into 3, that will be equal to 12 minus 6
Reaction
by
12 minus 6
12,
by 12 into 6.
6. So this cancels by 12 and this is cancelled by 6. So 12 minus 6 by 6.
So minus will come, sir, because
Yeah,
both
minus,
the
yeah.
moment is.
Yeah. Yeah,
Then
minus is this.
FBH I'm
Mhm.
getting 12 minus x by
Minus
6 root 2.
So I'm telling I will have it minus and I will say 12 minus 6, x minus 12 by 6.
Okay.
What about FBH?
12 minus x by 6 root 2 I'm getting.
12 minus x by
6
root
root
2.
2 I'm getting. Let's see
Okay.
what others telling. Then
FGH?
FGH is 12 minus x by 12 positive. 12 minus x by 12.
Just can you please confirm? Ramya, what about you? Is it you that's there?
Somewhere I made mistake, sir. Got stuck up.
Okay. Vishnu, 12 minus x by 6 root 2. Fine. FGH, 12 minus x by 12. I think these values are right, it seems. So first kindly note it down these values. I think these are right. I don't think these are wrong. And let's find out, or let's go to the ILD diagram and then. Can I go to the next slide? Have you guys noted down these three?
1 minute, sir.
Yeah.
Yes, sir.
Now, similarly, if the load is here, what is the x value I should consider? If the load is at C, what is the x value?
X value 6 meter.
X value is 6. So if the load is at point C or x equal to 6, can you tell me what is the force in the member BC?
It's -1, sir.
-1. Okay. So -1. These are looking clumsy.
Sir, you asked for FBC value, right, sir?
Yes, right. So I'm just overlapping with the diagram, so don't get confused, just to make it clarity. So here it is 0. Here you guys already said it is minus 0.5. And here you guys said it is -1. Isn't it? Now, similarly, can you tell me what is the force in member GH similarly at that point? If the load is at C, what is the force in the member GH?
0.5 tension.
0.5 tension. It is less than 3/4, right? So that's why I'm just drawing below that point. Similarly, what about my force in member BH?
1 by root 2, sir.
Positive.
Positive, sir.
So as it is a positive, I'm representing in the upward direction, 1 by root. I don't think you guys have any further doubt in these three values, right? Here the value I'm representing it as 0. Similarly, if the load is here, what about my x value?
It's
9.
9.
Can you similarly tell me, find out the what about the force in member BC, force in member GH, force in member BH?
FBC is -0.5, sir.
-0.5. So somewhere around here. GH.
FBH is 1 by 2 root 2.
Matlab, less than 0.5. So somewhere around here, 1 by 2 root.
FGH is 1 by 4, sir. That is 0.25.
0.25, that means less than this. This is 0.5. Now similarly, if the load is here, what about your x value? 12. Similarly, what about the force in these members? If it's equal to 12, I think directly you guys can say, right? 0, 0,
0.
0.
Everything is 0, sir.
Everything is 0, right? Now, join these plots. See, linearly. I have joined this plot and then join this, and then join this. Even though they are not looking exactly linear, but treat them as a linear. Here the ordinate is minus 0.5. Here the ordinate is minus 1. And again, here the ordinate is minus 0.5. Here it is 0. Similarly, for ZH, join them linearly, 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 linearly. So this is what I will do for GH. Now for BH, from here to here, join them. And then from here to here, join them, and then join them. Here, I think you have said 1/4. Is it find these values? ILDs, as you can observe now here. BC, if you see the look at the diagram, BC member is at the top. So it is under compression throughout the wherever the unit load is. Yeah. If you can see member BC, wherever the unit load is, the member is always under compression. If you see member GH, as it is a bottom chord member, wherever the unit load is, it is under tension. But if you look at the inclined member BH, as you can see, as it is the inclined member, it will have both compression and tension. So in between A to B, it is under compression, and then it will change it to the tension, and then 0. Is it clear about the ILD?
Sir.
You might feel like it will be lengthy, but if you practice well, and they will ask you only one ILD for one member, I think you guys can complete within 3 minutes, less than 3 minutes. It won't take not more than that. And also there is some logic. If it is a diagonal member, try to eliminate the options which are under directly compression and tension. If it is either top member or bottom member, directly eliminate the options which are having both compression and tension. So you have sometimes you have to go by the elimination also. So without doing any work, sometimes we might get the answer, but not always. So just for your practice, try to find out ILDs for force in member CD, force in member HD, force in member HI. Just for your practice. As of now, any doubts in ILD of process?
We'll practice those and we'll let you know, sir.
Okay, and then we'll start the new topic from next class. Let's wind up here today. Let's wind up at ILD.
Sir, we'll copy this, sir. Please give us a minute, sir.
Yeah. Yeah. As somebody will join, somebody might join in the next class. So let's start a new topic in the next class so that others can be interested in.
Next topic, is it arches, sir?
No, not arches. I'm just going by important topics.
Okay, sir.
Next, we might discuss indeterminate structures, it seems.
Okay, sir.
Still, there is some part of determinate structures. I don't know how much. I will guess centimeter is over for you or no?
Over, sir.
So there they might have given you some introduction about deflection of beams, isn't it?
Yes, sir. Yes, sir.
How will you guys have to find out? Unit load method they might have discussed. Are they? Or any other method, only conjugate beam method? So for determinate structures, if I speak about, we have to talk about, at least for determinate structures, we should see how to find the deflection slopes that we should know. And as we said, strain energy is just a formula or something. It won't take much time. Yeah, these small things that we can cover up in one class. That's why I'm just dragging it. So just let's cover the important topics, and then at last we'll finish it off by giving some info. So as of now, these are some very important topics for trusses, influence line diagrams, and indeterminacy. In the next class, we'll try to start indeterminate structures, and then we'll see what are the methods that we have to discuss. And that's it. And then determinate one, and then slightly about cables, slightly about arches. That's it. Okay. As of now, it's clear, right?
Sir.
ILDs, I think it's completed. So I will start a new topic from the okay. So you guys practice it and forward me if you guys having any doubts. We'll discuss. Okay. Shall we end the class?
Thank you, sir.
Okay, guys. Thank you. Thank you for your time. I think Monica Shiny, I don't know if he has just joined now. Sorry, Monica, for disappointing you.